Alright guys, another quick update for you before I head into work here. So I got my real-time clocks in. I got two of them. One's a DS1307. The other one is this guy that's wired up to the circuit right now is a DS3231. As you might have remembered, I mentioned this guy is a lot more precise. He has internal temperature control. So he's constantly making adjustments based off of temperature to ensure that his timing is accurate. So right now, what I'm doing is there is a pin on this guy, and we might see it, yeah, right there, that SQW, that's a square wave. So this guy he can keep track of time, the calendar time and everything, but he also generates these useful things. One is the square wave and one is this other pin back here. It's a 32 kilohertz pin out. But what the square wave gets us is basically just a signal that is literally a square wave that's high or low, high or low. So right now, that square wave is coming over here to pin 2 on the Arduino, and in code I have pin 2 set up as an interrupt. So every time he hits the high point on that square wave, we get a call into code. And all I'm doing right now, and I'll put this up on GitHub eventually, but I can show you what's happening, is that blink function right here gets called, and it's just a count. And as we run through our loop that just, successively runs each time, we check whether the count has reached 9 or 10. If it's 9, I set the pin high for the digital potentiometer. That's the other side of the circuit over here, which you guys have seen before, which causes the turn. And then when the count reaches 10, we set it low again and set the count back to 0. So I'm not exactly sure what the square wave is putting out. It definitely seems less than half a second. But the point is that we count each half a second chunk, and when we've reached the 9th one, we start turning, and when we reach the 10th one, we stop turning. And this just gives me what you're seeing here, an easy turn and enough time in between that I can read the heading. And the point of all this being is that I just did a little test of heading readings, and this will also get uploaded at some point. But these are the numbers I got just doing a small test. And as you can see, there is some variation here. Like, it seems 54.6 is our magic number in this test. We get 53 and 55 right here, and we get a 52 right here. But being off by 1 or 2 and maybe 3 in that direction compared to, and you can see these numbers over here from our earlier tests. I haven't done the math, but I think our percentages are actually lower than they were before in terms of variance. So I don't know if this is perfect yet, but it's going to be a little tougher for me to set up a test in CE because I basically have to set the timer to delay long enough for me to reset the checkpoint over and over again. But I'm going to try and do it and see if I get something that's a bit more consistent and see if we can move on with this heavy aim test in 5.